Hello, Algebra 2 students. It's your friendly neighborhood math teacher, Miss Sather. Today we're going to be finding an LCD, otherwise known as a least common denominator. You've done this before whenever you saw fractions for the first time a long time ago. So what we're going to end up with, let's take a look at 1/3 and 5/7. So whenever we want to add and subtract fractions, we want to make sure that our denominators, which are the numbers at the bottom, are exactly the same. So if they're already the same, then there's no point in this lesson. But if they're not, here are some things we need to do. A couple of things I notice about 3 and 7 are that these are both prime numbers. It means the only thing that divides into 3 is 1 times 3, and the only thing that divides into 7 is 1 times 7. So if you happen to have the case where you've got two prime numbers that really can't be factored, when you're trying to find your LCD, what you want to do is multiply those two things together. So it turns out that if I did 7 times 3, yeah.
Started.
Okay.
Three calls today. The first one, they didn't have a clue what they were talking about. They were with Sydney Road. Second one, the third party payer, which I can't stand because it just pisses me off that you own a business, a small business, and they're too damn lazy to pay their own bills.
Yeah, that's bad.
Fuck off. You need to close your business.
Yeah.
And then the third, they started cussing at me because somebody from our accounts payable sent her an invoice.
Oh.
What? You know?
Okay, that's fine. Let's try this one more time. Oh, let's try this one more time. No. You're gone. Hello, Algebra 2 students. This is your friendly neighborhood math teacher, Miss Sather. Today we're going to be talking about finding an LCD. An LCD is the least common denominator, and it's something that we need to have if we're going to add or subtract fractions. So the idea is anytime you add or subtract, you have to have the bottom of your fraction, the denominator, exactly the same. Not going to get into the details of why that's important, just know it is. So, our first example, 1/3 and 5/7. Hello, Algebra 2 students. This is your friendly neighborhood Algebra 2 teacher. Today we're going to be doing finding a least common denominator, or an LCD. When we add or subtract fractions, what we need to do is make sure that the denominators in this first problem, the numbers like 3, Hello, Algebra 2 students. This is Miss Sather again. Today we're going to be finding an LCD. LCD means least common denominator. And when we are working with fractions and we're trying to add and subtract, what we need is for the bottom numbers, the denominators, to be exactly the same. And if you notice right here on this 1/3 and 5/7 problem, they are not the same. One fraction has a 3 and the other one has a 7. There's a couple of tricks to dealing with this that are going to lead us into how I suggest working with rational denominators. The ones that have x in them. If your denominators are prime, meaning they're not going to factor, such as 3, the only way to get 3 is to multiply 1 times 3, and the only way to get 7 is to multiply 1 times 7, so that means they're prime. If you have two prime factors, what you want for your LCD is to just multiply those two things together. So here, our least common denominator is going to be 3 times 7, or just 21. All right, so to make that happen, what we need to do is multiply each of the fractions. So we're going to take our 1/3. If I want to make 1/3 into something over 21, what I'm going to need to do is multiply my fraction by 7/7. Now 7/7 is a fancy way to write the number 1, so we're really not changing the fraction, we're just giving it a makeover. So if you multiply straight across the top like we did last week, you end up with 7 on the top of this fraction. And you end up with 3 times 7, or 21, at the bottom of the fraction. We can do this again with 5/7. If we have the fraction 5/7 and we need to make the denominator 21, now we're going to multiply this fraction by 3/3. Again, a fancy way of writing the number 1. And we're going to multiply this. We can do this again with 5/7. So to make 7 into 21, we need to multiply by 3. So if we multiply the fraction by 3/3, again, a fancy way of saying the number 1. We're not really changing the fraction, we're just giving it a slight makeover. So 5 times 3 is 15, and then 7 times 3 would be 21. And now, whenever we look at these, we have two fractions that have the same denominator. The LCD would be 21. Right, so I'm going to do this again, but with a fraction that's a couple of fractions that are a little different. 3/4 and 7/10. So this time, 4 and 10 are not prime. There are several things that multiply together to get these terms. If you think about the number 4, you can multiply 2 times 2 to get 4. And if you think about the number 10, you can multiply 2 times 5 to get 10. Okay. So with that, one of the things about these, we could look through our lists of factors that we've used and see, which ones are the same and which ones are different. So I know that both of these terms, things that they have in common, they both have a 2. When I look at both sets of factors, I could look for things that they have in common. So let's see if we can write some of the common terms. In common, they both have a 2. So there's a 2 in this list, there's a 2 in this list. Things that are not common, we need to know what those are. So things that are not in common, they have a 2 when we're looking at our first set of factors, and then the second fraction has a 5 that's not in common so far. Now, what we want to do is put all of these common and not common factors together in a nice little row. So if we did 2 times 2 times 5, 2 times 2 is 4, 4 times 5 is going to be 20. That's how we can get our LCD. So this time it's going to look a little bit different. Okay, so let's go back to trying to calculate some LCDs. If we have the fraction 3/4, we want to make that 4 into a 20. So that means we're going to be multiplying our fraction by 5/5 this go around. If you multiply straight across the top, we end up with a 15/20. If we take our other fraction, that's 7 over 10, we want to turn that 10 into a 20, and the best way to do that is to multiply by 2 over 2. So now we get 14 over 20, and we have our two fractions that now have a common denominator. So you might notice if you're looking at our factors, whenever you're trying to figure out what to multiply by, it's always by the one thing or two things or however many that are not in the not in common list and not in your particular fraction. Skip it. All right. Now let's move to the big kid fractions, right? So these are the fractions that have x in them. So one of the first things we need to do before we try to even find an LCD is kind of what we did in the last example. We need to factor our denominators. So let's change this up a little bit. We've got the fraction 2 over x, or 2 times x over and when we're doing these, we need to factor. That would be our first step. So our first fraction is 2 times x divided by, all right, so we need to factor x squared minus 3x minus 10. And I think if we consider numbers that multiply to be negative 10 and add to be negative 3, we're going to end up with the factors of x minus 5 and x plus 2. We take our other fraction and we factor 3x minus 15. Either 3x and the 15 are both divisible by 3. So that leaves us with a 3x minus 5. Now, just like we did on the last problem, we can go through and we can make a list of things that they have in common and things that they don't have in common. So the common things, you're going to have, starting with the fraction on the left, you're going to have an x minus 5. Okay, and the fraction on the right has an x minus 5 as well. The not in common things, we also need to include those. On the left, you have an x plus 2 that isn't in the fraction on the right. We also have the number 3 that is on the right, but not on the left. So whenever we put together our LCD, we need all of these things. So the LCD is going to be x minus 5, x plus 2, and the number 3. Okay, so let's see what we need to multiply by to make these things have a common denominator. So let's start with the 2x fraction. 2x over x minus 5, x plus 2. If I look at my LCD list, we have the x minus 5, we have the x plus 2, but we are missing the number 3. So what we want to do is multiply by 3 over 3. So this ends up being 6x over, I'm going to put that 3 in the front, 3 times x minus 5, x plus 2. And then if we do the other fraction, we have the x minus 1 over 3 times x minus 5. It looks like that fraction is missing the x plus 2 piece. We're going to multiply times x plus 2. Okay, so as this is happening, we're going to go ahead and multiply everything out. So at the top, you're going to end up working with x times x, x times 2, negative 1 times x, and negative 1 times 2. And when we do that and simplify all of that, we get x squared plus x minus 2. Okay. And if you're wondering where I got the positive 1x from, if you do x times 2, that would be 2x. And if you do negative 1 times x, that's negative 1x. 2x minus 1x is 1x. Okay, so that's how we got that And now both of our fractions are going to have the same denominator. Okay, let's try one more, and then we'll call it a day. All right, last one. So here we have x minus 4 over x squared minus 9. We have 2x plus 3 over x squared plus 11x plus 24. All right, so let's see how this goes. If we take our x minus 4 fraction, that denominator is a difference of squares. So if you find the square root of x squared and the square root of 9 and write those in the form we've learned before, you get x plus 3, x minus 3. If you take the other fraction, the 2x plus 3 fraction, and you factor and figure out things that multiply to be 24 but add to be 11, I think we're going to end up with x plus 8 and x plus 3. All right, so if we think about things that they have in common, they both have an x plus 3. So that's got to be part of our LCD. So we've already done that. That piece is accounted for. Then we need to write down the other pieces. So we are missing the x minus 3. Okay, so that's done. And then we also need that x plus 8. All right, so now that I've written down everything that's in the denominator, I now know what my LCD is going to be, and then I can work on applying that. So the first fraction, we're going to take our x minus 4 fraction and multiply it by the term that's not there. The term that's not there in this case is x plus 8. So x minus 4 over x plus 3, x minus 3, and then times x plus 8. Okay, so as I'm working this out, what I'm noticing, if I do that distribution on the top, we're going to have x times x, which is x squared. If we multiply x times 8, we get 8x. Negative 4 times x is negative 4x. If you add 8 plus 4, you get positive 4. And then negative 4 times 8 is negative 24. All right, and then we can just write our LCD, our x plus 3, x minus 3, and then x plus 8. All right, if we do our other fraction, the 2x fraction, or 2x plus 3 fraction, you got 2x plus 3 over x plus 8, x plus 3. This fraction is missing the x minus 3. Okay, so what we need to do is go ahead and distribute. So 2x times x is going to be 2x squared. 2x times negative 3 is negative 6x. 3 times x is 3x. Negative 6 plus 3 is negative 3x. And then 3 times negative 3 is negative 9. And we just write our denominator at the bottom. And that, my friends, is how you get least common denominators when you're working with rational functions. You'll be needing this to apply later whenever you take a look at adding and subtracting. So have a great day and hope you learned something.